Hey guys, for lesson 4.3, we're going to talk about three different properties that come up. We've got a perpendicular bisector, the midsegment theorem, and an angle bisector. A perpendicular bisector is a line that divides a line segment into two equal parts. So perpendicular meaning that it meets at 90 degrees, and bisector meaning that it cuts it in half to be perfectly. So if you look at these two examples, DE is the perpendicular bisector. Perpendicular bisector. And then for the one on the right, CD is the perpendicular bisector. And what you'll notice is that 12 equals 12, and here 11 equals 11. So this piece is the exact same length as DB. AD is the same length as DB. And similarly on the other side, I don't know why I keep starting on the right, but AB on the left is the same length as BC. So knowing that property is going to help you with setting up and solving a bunch of variety of questions that you're going to be given. So let's look at a couple. Given that AB is 21 feet, so AB is 21 feet, and BC is 2x plus 3, we know that DE is a perpendicular bisector. That tells me that theorem that I've got two equal pieces right here. I want you to solve for x. So pause your video and think, okay, these two pieces are congruent. How am I going to solve this? Pause the video, try to solve it. When you're ready, you can come back and we can work through it together. Okay, so since these two pieces are equal, I'm going to take length AB and I'm going to set it equal to BC. So 21 equals 2x plus 3. Simple solving from here, subtract 3 on both sides. I have 18 equals 2x. Divide by 2, x equals 9. So x equals 9. So if I were to plug in 9 for that x, I of course would get 21, but I already knew that was going to be 21 because AB is 21. Okay, so for this next one, we have AB is 3x minus 4, BC is 7x minus 16. Those two pieces again, AB is congruent or is equal to BC. And I should say that they're equal and not congruent because congruent is talking about figures being congruent. And equality is talking about measures being equal. So AB is 3x minus 4, setting that equal to 7x minus 16. Solving from here, we're just trying to isolate the x and solve. So we have, I'm going to add 16 over first because I don't like any negative numbers. So plus 12 equals 7x. Subtract the 3x on both sides. 12 equals 4x, divide by 4. X equals 3. But be careful because the actual question is asking for the length of AC. So the length of AC is the entire length here. So think to yourself, what do I have to do in order to solve for the entire length of AC? I'm going to plug in the x into one of my equations because I only really need one. So 3 times 3 minus 4, that's 9 minus 4, which equals 5. So that means that AB is 5, but by the perpendicular bisector theorem, we also know that BC is also equal to 5. Therefore, AC is equal to AB plus BC, which is 5 plus 5, which is equal to 10. Pretty simple. All right, let's look at another example. Given that AB is 24 feet, so AB, the entire length this time is 24, and CD is 9, and CD is a perpendicular bisector, we want to find the lengths of AC and BC. So you should already be kind of thinking, these are two right triangles. How did we solve for sides when we were given a right triangle? Well, we used the Pythagorean theorem. So in this case, if the entire length of AB is 24, that would tell me that AD is 12 and DB is 12. So now I've got this fancy little right triangle going on, 12 and 9, and it's asking me for AC, which is the hypotenuse of the triangle. So I'm going to do a squared plus b squared, and that's going to give me my hypotenuse squared. So it doesn't matter which one you choose as a and b, so 12 squared plus 9 squared equals c squared. That's going to give me 144 plus 81 equals c squared. 225 equals c squared. To get rid of the squaring, we have to take the square root. That means that c, or in this case AC, is equal to 15. So this guy right here is equal to 15. And since this triangle on the right has the same height and the same base, That means that BC would also be equal to 15. All right, one last example of perpendicular bisectors before we go on. Given that CA is 25 and CD is 15, and CD is a perpendicular bisector, find the length of AB. So I'm going to set up the Pythagorean theorem again, but this time I'm solving for a leg of the triangle. That leg is going to give me half of the total distance of AB. So if this is my triangle, I'm trying to solve for this length right here. I've got 15 and 225. 225. Whoa. 15 and 25. And that's going to be C this time. So we have like A, B, and C. So x squared plus 15 squared equals 25 squared. X squared plus 225 equals 625. Subtracting 225 from both sides. X squared equals 400. Square root. X equals 20. So AD is equal to 20. And by that perpendicular bisector theorem, DB is also equal to 20. So AB equals AD plus DB. Let me show you that with some highlighters so that you can get a better idea. So AB, which is this guy, plus DB. I highlighted the wrong one. AD, there we go, this guy, plus DB, which is this guy, will give me AB, which is this guy. Okay, so our 20 plus 20, that means that AB equals 40. Be careful here. Usually when you're talking about units, so if I give a triangle units, you want to make sure that you include units in your response. All right, this leads us to the mid-segment theorem, and this is kind of a fancy one that we have. So it's a segment formed by connecting two of the midpoints. So we have a triangle, and D is the midpoint of AB, and E is the midpoint of AC. And what happens when we have a midpoint, because a midpoint is kind of like a bisector. A midpoint is the very middle and it cuts my segment into two equal pieces. So you're going to have this congruency where this is 10 and this would also be 10, and this is 12 and this is also 12. So that's one part of the theorem. But we can also talk about the lengths of the bases of the two triangles. So if this is a midpoint here, D and E, then I have this property where the length of the base of the small triangle is going to be half of the length of the base of the big triangle, or the length of the base of the big triangle. So let me write what I'm saying. The length of the base of the big triangle, and what I mean by big triangle is, obviously the bigger one and there's a little one inside, is 2 times the length of the base of the little triangle. Okay, and we're going to be able to solve these different theorems using that idea. So here we have that DE is the midsegment. That means that D and E are both midpoints. BC is 30, so what is DE? Okay, and by that theorem we just talked about, this would be equal to 2A, and DE would be equal to A. So I can actually set equal 30 to 2A in order to solve for what A is. So divide by 2, A equals 15, therefore DE equals 15. So given that DE is the midsegment and AC is 14, what would be DC and AD? So by the midsegment theorem, if I have a midpoint D and the whole length is 14, that means these small lengths will be 7 and 7 because 14 is 7 plus 7. So AD equals 7, DC equals 7. All right, for my next one, I have given that the midsegment is DE. DE equals 2x minus 8, and BC equals 32. So notice that I always start by labeling the triangle so that I can see visually what's going on. We know that 32 is equal to 2A, and this would be equal to A. So I'm going to solve for A first. I think that might be the easiest thing to do. There's different ways to solve it. You might see a different way, and that's totally fine. But 32 equals 2A. That means that A is going to be 16. So I can take the fact that a is 16 and take 2x minus 8 and set it equal to 16 and just solve like a normal two-step equation. So x equals x equals 12. So if this is going to be 12, we also know that this would be 16, and that's the midsegment theorem. Okay, one more example. Actually, I think we have two more. Yep, two more. So given that DE is a midsegment of ABC, AD is 2x plus 8, and DC is 4x minus 2. Find the entire length of AC. So I need to first solve for x in order to find the lengths of those small pieces. And I know that because this is a midpoint and DE is a midsegment, that AD is equal to DC. 2x plus 8 is equal to 4x minus 2. Add 2 on both sides. I'll get 2x plus 10 equals 4x minus 2x on both sides. 10 equals 2x. So that means that x equals 5. But this is not the length. So in order to solve for the actual length, I have to plug in that value. And I can plug it into both, so that's going to show me that it's the same length. So 2 times 5 plus 8. So 2 times 5 is 10 plus 8 is 18. 4 times 5 minus 2 is also 18. So that gives me that AC is equal to 18 plus 18. AC is equal to 36, and we are talking about, doesn't give me a unit, so I'm just going to say units. Okay, DE, EF, and FE are all midsegments. So these are all big triangles. There's like 3 big small triangles in here. So these are all midpoints. Okay, AB is 12, and automatically that should tell you, okay, so I don't like that line. Automatically, that should tell you that AD is 6 and DB is 6. BC is 22. So that tells me automatically BF is 11 and FC is 11. And then we have AC, of course. AC is 20. Whoa. AC is 20. That means that AE is 10 and EC is also 10. So from here, what we can do is we've got a bunch of the midsegment theorems going on. So the base of AB is 2 times the length of the base of EF. So if AB is 12, that means EF has to be half of that, which is 6. And similarly, if BC is the base of the big triangle, it's 2 times the size of the base of DE, so that means that DE would have to be 11. And by similar knowledge, AC is 20. Half of 20 is 10, so that would have to be DF. So those are the different answers for this different paragraph. All right, and this leads me to the angle bisector theorem. The angle bisector theorem tells me that I have an angle, it's divided into 2 equal pieces, okay? And as a result, 2 equal pieces, so there's something cutting the angle in half. So if the total angle is 40, if I have an angle bisector, that means each angle would be 20 and 20. But we also have these cool little proportional side lengths going on. So one triangle's hypotenuse, kind of like an hypotenuse, but we don't know if it's 90 degrees. But one side triangle's length over another length, C, is going to be equal to the proportion of B over D. And we're going to apply that to different questions. First one, pretty basic. We have an angle here. It's being bisected. So we know that these 2 measures right here are going to be equal to each other. So we're going to solve for x. So that will tell me that x plus 7 equals 2 times 3x minus 4. X plus 7 equals 2 times 3, which is 6x, minus 8 minus 7. X equals 6x minus 15, minus 6x on both sides. And of course, you could have solved it a different way than I just solved it because I have negatives on both sides, which really is kind of annoying. But doesn't matter. I'm going to be dividing by a negative 5. X would equal 3. So if I want to solve for the angle, it kind of doesn't make sense, but 3 plus 7 equals 10. That angle is 10, so this angle would also have to be 10. You also are going to see that what's going to happen is that these two lengths, if we have perpendicular lines drawn from AB to AC, these two lengths are congruent, so you can also set these two lengths equal to each other if the problem were saying that. Okay, the last one we're going to talk about is those proportions. So just to kind of refresh your memory, we had something that looked like this on an earlier slide. This was a perpendicular, or an angle bisector, excuse me, so this was an angle bisector, so these two pieces were congruent. A, C, D, and B. So it's turned around and it's flipped around, but I can, if I give you the entire length of 36 and I give you a piece here, that means I can obviously, just by subtracting 36 minus 15, find that this little guy is 21. Okay, 21 correlates with the missing piece, and 15 correlates with the 30. So that's going to be 21 over x equals 15 over 30. You could have also written it as x over 21 equals 30 over 15. From here, you're going to cross multiply. So when I cross multiply, I get 630 equals 15x. Divide by 15 on both sides, x equals 42. So hopefully this lesson wasn't too tricky. It's just 3 different theorems that we learned today. So work through the practice. The key was going to be posted, so let me know if you have any questions.